selection pressures. What are those things that push giraffes to have really long necks, or moths so they could look exactly like twigs on branches, or peacocks? Why do they have that really crazy long tail? So let's talk about some examples of selection pressures. Predators are a fabulous example of a selection pressure, right? If you have something that's going to let you get away from the predators, you're going to have more offspring, right? So if you are faster, you're going to get away from a predator. If you have some sort of weaponry, you're going to get away from a predator. If you have camouflage or mimicry, those are all ways to get rid of predators. Prey or food, right? Any kind of adaptation that's going to allow you to get more food, we would generally see that you would have more offspring. So things like speed, senses for finding the food, weapons for killing the prey, camouflage for stealth. We're also going to see climate, right? If you can survive in one climate, when it changes, then we're going to see those that have more kids afterwards. So if we have like an ice age, or if we have a change in climate, like a really warm period on the earth, we're going to see changes in the kinds of creatures that live there. When we have mates, then we're going to have different pieces. So if you have something that will allow you to attract a mate, then you're going to have more offspring than if you don't have that. Right? So if you're strongly attractive, or if you're a good provider for the nest, right? So let's give an example for predators, right? The leaf bug, right? So the selection pressure is predators. And so if you mimic a leaf, you're not going to be as likely to be eaten. And so you can escape predation that way. Example 2, if we want to look for obtaining food, then we have the giraffe and the really long neck, right? The acacia trees got taller, the giraffes got taller together. We can also look at climate, where we can see on the left a rabbit who is in the desert and has very long legs and very large ears. And if we look on the right, we're going to see a similar species, only they're adapted for a very cold climate. And so they're going to have a more compact body and shorter limbs to keep that heat together. That's actually called Allen's rule. Sexual selection is traits that show fitness to potential mate. So peacock tails show female peacocks that they are they're going to be good fathers to the kids, or provide good genetics to the kids. Deer antlers do the same thing. Songs, right? Whenever we hear bird songs or frog songs or cricket songs, those are all members of those species advertising how fit they are, or what a good father they would be. We also see mating dances by birds primarily, although you see them in some other species as well. So let's talk about the selection pressures. Selection pressures actually can push you in a specific direction, right? We call that directional selection. And so we're going to favor one extreme of the population for a trait. And that's going to happen when the environment changes in a very consistent way. So if the climate gets colder, we're going to be talking about directional selection. We could talk about disruptive selection, and that is where the natural selection is going to favor both extremes of the phenotypes that are seen. And that's going to cause species to diverge and break up. We're going to have stabilizing selection, and that's going to favor kind of the average of the population that's selected. And then, of course, we have sexual selection, which is showing that you would be a good mate to the people around you. So directional selection is going to be an example for like the neck of a giraffe, or an antibiotic resistance of bacteria. Nocturnal beavers are definitely directional selection. And we also have camouflage and mimicry are definitely directional selection. Many sexually selected traits like peacock tails are directional selection. So we can have mimicry, right, where we're actually going to mimic the environment. That's an example. So we've got a stick bug that's going to look like a stick. We've got a caterpillar that looks like a snake on his end, so you wouldn't want to eat him. We have a moth that looks like a twig, so it wouldn't be a good, easy target for the predators. Disruptive selection is going to favor the two extremes, and so we're going to cause a divergence within the species. We're going to form two species from that. And that is going to occur when two different types of resources are found in one particular area, and that's going to result in kind of stabilizing those two extremes, and that is how we get new species. So you can see this in finches when they are forming in different kinds of finches. Stabilizing selection says that the extremes are not well suited and the middle section is. So bird clutch size. You don't want to be a bird and only have one egg at a time. You're not going to reproduce quickly enough to stay current with population. You likewise don't want to have so many babies you can't take care of them. Elk antlers have a maximum size because at some point you can't lift up your head and then you can't eat. So we want to make sure we don't have the extreme for elk antler size. Giraffe neck length is currently being stabilized, and tail length in birds. Sexual selection produces traits that show fitness for your potential mates. So we have an example like a peacock tail, deer antlers, songs, definitely